All right, folks, just another quick pre-lesson for section 6.4. I realize at the point you're watching this, you still have not necessarily been through the whole lesson for section 6.3. So I'll keep that in mind. We should still be able to handle it, and you'll see a couple stars already in place where it will make more sense after going through section 6.3. Okay, so first off, we're just working with equations that we've already seen before in this course. You'll notice the general equation for transformations in function notation. We've seen this already. Most recently, we saw this in section 3.4, but we also worked on this in chapter 1, where we have our A, K, P, and Q values to represent our transformations that are being applied to our base function. In this case, our base function would be given by f at x. Now, when we're working with sine functions and cosine functions, and those are our sinusoidal functions, then the equations look like so. So you can see how A, K, P, and Q are still in the same spots, the same locations in the equation, but this time, obviously, the base functions that we're working with are the sine and the cosine functions. Now, you'll notice, as has been a common pattern so far, the horizontal transformations, and those come from K and P, the horizontal transformations happen inside of our base function. In this case, it's sine or cosine. The vertical transformations are applied outside of this base function, and those are given by A and Q down here. A and Q on the outside of the sine and cosine functions. All right, now let's just look forward. We're just mostly going to go over some terminology here. Looks like I have about 3 minutes left. We're going to go over some terminology. So we have here just a complete rehash of the transformations we've already covered, right? Where A is our vertical stretch or compression factor. If A is less than 0, there's also a vertical reflection, which means it's being reflected over the x-axis. 1 over the absolute value of K is our horizontal stretch or compression factor. And if K is less than 0, so if K is negative, then we have a horizontal transformation over the y-axis. P is our horizontal translation. Q is our vertical translation. Well, specifically, when we're working with sinusoidal functions, then these transformations actually apply to different characteristics of the sinusoidal function. We are going to go over what these characteristics look like a little bit more. We're going to review that because you will have already gone over that in your grade 11 course. But specifically where we're looking, the absolute value of A, and that, remember, was our vertical stretch or compression factor, that applies to our amplitude. So if A equals 1, our amplitude is 1. If it's vertically stretched, and that makes sense, then we're expecting the vertical height of our sinusoidal function to be increased proportionately. Now, a horizontal stretch or compression factor, that will directly affect the period, and you'll see this 2 pi over K, that might look pretty funny to you. That'll make a little more sense after we go over section 6.3. The horizontal translation, that comes from P. We just call that a phase shift when we're working with sinusoidal functions. We just happen to use that terminology, so you need to be ready to hear it. And a vertical translation, that it gives us our axis of the curve. So if it's being translated 4 units up, then our axis of the curve would be y equals 4. All right, now, again, recalling from section 3.4, where we learned how to graph our functions by transformations. When we graph by transformations, we need to work with our transformations in a specific order, and that is working with our reflections first, our stretches and compressions second, and our translations third. That should be enough to get us ready to handle this lesson here. It looks like I have another 30 seconds. I didn't even need it here. You should be nice and ready. And I'm just kidding, folks. I am back. I know if I have 30 seconds, I'm going to use them. So if I look here at a sinusoidal function, I'd just like to point out these characteristics because they should be a review from grade 11. All right, so your amplitude is measured from the axis of symmetry, and that's the middle of your curve. The axis of symmetry up to the highest point, or from the axis of symmetry down to the lowest point. So these here are your amplitudes. Now, well, this is your amplitude. They'll both measure the same. Now, your other vertical transformation is your axis of symmetry. Well, your axis of symmetry is given by y equals q, and that is the axis right in the middle, vertically right in the middle of your curve. It's halfway between the maximum and the minimum down here. Now, your axis of symmetry, let me see here, is also, as I shared before, that's your translation. So in this case, the axis of symmetry would have been translated up above the x-axis. Now, your phase shift, and that's your horizontal transformation, if we're assuming this was a sine function, then your phase shift would be right here. And that is the amount that your function has been picked up and moved from its original position, the amount that it has been translated horizontally from its original position. And lastly here, we have our period. And the period is the amount of time it takes for your periodic function, and your sinusoidal functions are periodic, the amount of time it takes for your periodic function to start repeating itself. So if your function begins here, it goes up and down and back up, and that's your period, because then it's starting to repeat itself. It's going up and down, and we can assume that its shape will continue in that manner. So your period is the horizontal distance from the beginning to the end of one rotation around here. That's it. That's the last one. I will see you in the lesson.